This is a continuation of Lesson 1-9, Scientific Notation. Okay, so this is Part 2. So example 4 says we want to write numbers in scientific notation. So we want to write these numbers in the form something times 10 to the something, where this first something has to be greater than or equal to 1 and less than 10. And then this something up here, this is an exponent that tells us which way we are going to move the decimal. It tells us if we are going to move it left or right. So for example, for A, we have 8,785,000,000. This is the number that we are starting with. Now, because we have a very large number, that means that my exponent is going to be positive, okay? So we want, right now, the decimal is right there. And we want to take that decimal and we want to move it to the left until we get to our first something that is greater than or equal to 1 and less than 10. So we will move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 8.785 is greater than or equal to 1, it's greater than 1, and it is less than 10, and that's what we're looking for. So when we write down our scientific notation, we're going to write this first part to 1, 2, this is going to have 4 significant digits, okay? So that's going to be 8.785. See these zeros, these trailing zeros, we don't need them, times 10, and how many times did we move the decimal? 9 times. And that's how we put that, that's how we get our scientific notation. Okay? So for the next one, for this 14,140,000, we're going to take that decimal, and again, the decimal is at the end, okay? And we want to move that decimal 1, 2, 3, 4, 5, 6, 7 times. We want to move the decimal to the left until we get to a number that is greater than 1, greater than or equal to 1, and less than 10. So this is going to give us 1.414 times 10 to the 6 to the 7th power. All right, so for example 5, we want to write these in scientific notation. And notice we have numbers that are very small. We have numbers that are very small. So if we have numbers that are very small, that means when I write those numbers in scientific notation, our exponent is going to be negative. All right, so make sure you write this down. If you are starting out with very small numbers, your exponent is going to be negative when writing in scientific notation. So here, we're starting out with very small numbers. We're going to, right now, there's the decimal. Okay, there's the decimal. And we want to move the decimal so that my first something is greater than or equal to 1 and less than 10. So we're going to move that decimal to right there. So our first something is 5.24. And then it's always times 10, and the second and the exponent, we move the decimal 1 time, so that's going to be times 10 to the negative 1. Okay? So here, for example, 5b, our decimal is right here, and we're going to move that decimal to the right until we get to a number that is greater than or equal to 1 and less than 10. So this is going to give me 8.76. Okay? So here we've got, this is our first factor. That's the factor that we're writing down. That's the factor we're writing down, 8.76. times 10, and we move the decimal 3 times, 1, 2, 3. So this is going to be a negative 3. So make sure that you write this down. This is the rule. If it's a very large number, then our exponent is going to be positive. And that's what we have right here. Okay? Make sure you write those down. Now, you heard us say significant digits. Okay? Now, significant digits tell us the accuracy of a measuring device. A greater number of sig digs, that's what they call it, significant digits. A greater number of sig digs means that the measuring tool has a greater precision. Okay? For example, here if we have a ruler only measured in centimeters. Okay? If a ruler only measured in centimeters, then a pencil that measures 18 centimeters potentially ranges from 17.5 to 18.49 centimeters. If a ruler measured in millimeters, then we could measure to the same pencil to 8.2 centimeters, okay? So if we're looking at the ruler, so here is an illustration of what we were just talking about. So if we have a pencil that measures, if we're measuring it in centimeters, if I have a ruler that measures in centimeters, then the closest I can get would be to right here in centimeters would be 18 centimeters. That 18 has two significant digits, 1 and 8. Okay? Now, we're looking at the same pencil with this same ruler now, and we have millimeters, okay? Then you can see that, let me see if I can do this. You can see that this actually measures to 18.2 centimeters. So 18.2 centimeters, this is 1, 8, and 2. This would be 18.2, that'll be 182 millimeters. So that's 18 centimeters, 18.2 centimeters. Whereas if it was just, if I did not have these lines in here, that would just be 18 centimeters. So that says that the ruler that measures in millimeters has a greater precision. So for example 6, we want to choose the units of appropriate size. Okay, so for example 6a, it says you are measuring a plant cell diameter. Is it more appropriate to report the diameter as 1.3 times 10 to the negative 8 kilometers, or would it be more appropriate to report it as 1.3 times 10 to the negative 2 millimeters? Okay? Now, if you think about the size of a kilometer and a millimeter, and you think about what we're measuring, a plant cell diameter, are we going to use kilometers or are we going to use millimeters? We're going to use millimeters. So the best answer would be this one. Okay? In example 6b, it says, in an ocean, the seafloor moved 475 kilometers over 65 million years. Now we want to know, is it more appropriate to report the rate of movement as 7.31 times 10 to the negative 6 kilometers per year? Or should we say 0.731 centimeters per year? Okay? And again, we want to think about how much it has moved over this long of a time, okay? And if we're talking about per year, and this is 475 kilometers over 6 million years. That's really teeny pieces of movement each year. Does everybody understand that? Okay. So do you think we would more appropriately report it as kilometers per year or centimeters per year? This one again would be centimeters per year. So for example 7, we are going to estimate with scientific notation. It says the distance from the Earth to the Moon is 283,900 miles. We want to write an estimation in scientific notation for the distance. Okay? So first thing we're going to do is we're going to write down our number that we're dealing with. So we're going to write down 238,900 miles. Okay? We want to write this in scientific notation. So the decimal right now is at the end. So we want to move the decimal 1, 2, 3, 4, 5 times to the left. So this is going to give me 2.389 times 10 to the 1, 2, 3, 4, 5, to the fifth power. So this is our scientific notation in miles. So when I am writing an estimation, we're going to take this first part, we're going to take this the first digit, and then we're going to move our decimal 5 times. Or actually we're going to move our decimal 5 times. 1, 2, 3, 4, 5. So this is our estimation. So the distance from the Earth to the Moon is about 200,000 miles. All right, example 7b says the diameter of a plant cell is 0.005136 centimeters. We want to write an estimation in scientific notation for the diameter. So again, we're going to write down the original number that we're starting with, 0.005136. Okay? We want to, and this is centimeters, we want to move the decimal to the right on this one until we get to a number that is greater than or equal to 1 and less than 10. So we're going to stop right there. So this is going to give me 5.136 times 10 to the negative 3, and that's centimeters. Okay? And again, we're going to take this first number, so this is going to give us 5 times 10 to the negative 3. And that number in standard form is 0.005 centimeters. And that is your estimation, okay? If they asked you to write it using scientific notation, let's do both of these. If they asked you to write it in scientific notation, then you would write 2 times 10 to the 5th miles for this one, and that gives you the 200,000 miles. And then on the second one, you would write 5 times 10 to the negative 3 centimeters. And then that's what this would give you, the 5,000 centimeters. So for example 8, we are comparing using scientific notation. It says you can use the power of 10 in scientific notation to determine how many times larger or smaller one number is than the other. We want to compare the following numbers. So here we're going to compare 1.6 times 10 to the 14th and 1.48 times 10 to the 10th. Okay, so we want to know how many times larger or smaller one number is than the other. So the first thing we need to do is we need to have the same, powers of 10. So example 8 is comparing using scientific notation. So we can use the power of 10 in scientific notation to determine how many times larger or smaller one number is than another. So we want to compare these two numbers. So I want to take this and I'm going to divide, because we're comparing how many times larger or smaller one is than the other. So we're going to divide this first number divided by the second number. So we've got 1.6 times 10 to the 14th over 1.48 times 10 to the 10th. Okay? So now all you have to do is use your calculator to put it in. And we know how to put it in the calculator, so this is what it looks like when we put it in the calculator. So you're going to put in, and in scientific notation, you're going to put 1.6, and then the EXP button, 14, and then you're going to divide by 1.48, and then the EXP button, and then 10, and then equals. So that's going to give you, so again, this, you guys, this is in the calculator. That's what it looks like in the calculator. Okay, so this is times 10 to the 14th, and this is times 10 to the 10th. So when I do that division, I'm going to get 1.08 times 10 to the 4th. Okay, now if I want this in standard form, this is going to be 108, if I move my decimal 4 times, 1, 2, 3, 4, this is going to be 10800, so that means that first number is about 11,000 times larger than the smaller number. Okay, so we can do the second one also. So we're going to divide 8.32 times 10 to the 5th divided by 7.54 times 10 to the negative 12. Okay, so that's the larger one, this is the smaller one. Okay, now in the calculator, what it's going to look like, it's going to say 8.32, and then it's going to be times 10 to the, it's going to say 0.5 up there, divided by 7.54 times 10 to the, it's going to say negative 12 up there. That's what it looks like in the calculator. So now when you type it in the calculator, you're going to type in 8.32, and then the EXP button, and then 5, divided by 7.54, EXP button, 12, and we want this to be negative, so don't forget to press the negative button, and then equals. So this, oh my gosh, that is a gigantic number. So this is going to be 1.10, see we have 3 significant digits, times 10 to the 17th. Oh my gosh. Oh my gosh. That's a gigantic number. So it's that many times bigger. So this larger number is that many times bigger than the smaller number.